Well, welcome to the July AWPUG Meetup. Today, our wonderful food was sponsored by Object Rocket. They didn't send anybody. Yep. Nobody came to talk about Object Rocket, but Object Rocket's pretty cool. If you are interested in using MongoDB and you don't want to actually manage it, you should look at Object Rocket because they have it all tricked out where you just say, I want a Mongo cluster, and you scale it for me, and they do all the dirty work behind the scenes. So it's really cool. I believe they're hiring, but I did not get any feedback from they just want to sponsor and be part of the Python community, so thank you to Object Rocket. Coming up, there's a few things coming up in the calendar. We have DjangoCon coming up soon. If you wanted to submit a talk, you missed out by a few days. It closed on the 15th, so shame on you. But I believe the conference is still open for registrations. It's in Portland on August 30th, over Labor Day weekend. And also we have PyTexas, which is in October. And Jeremy wants to talk about that a little bit. All right.
I also want to say we just switched over to Object Rocket over the last few months, and it's amazing. And so if you're managing your own Mongo clusters, stop. PyTexas is October 3rd through 5th. We have just extended the early bird deadline through this weekend. Prices are currently $55, which is a pretty reasonable price for a conference. We go up to like $99, I think, after this weekend. So if you're interested, over the next couple of days, go register at pytexas.org is the site. And we still have our call for proposals open, and that's going to be ongoing till like August 22nd or so. We have a lot of good talks already. James Powell from New York is coming down, I think, and if you haven't seen him talk, you really, really should. So really, we're welcoming any and all talks that are coming in. So take a look, pytexas.org. And one last thing, I am still looking for sponsors. I'm the sponsor chair for PyTexas this year, so there are opportunities. We have one slot left on the t-shirt, if anybody wants to pay $1,000. There is an opportunity for like being our exclusive bag sponsor, or lots of smaller sponsorships available, even down to the individual level, around $200. So anyway, please get in touch with me if you have any questions. I'll be happy to answer. Joe, what would you?
Is there a hotel?
So yeah, right. If you went to PyTexas last year, you might have noticed that we screwed up on the hotels at the end. Last I heard is the deal was sort of finalized yesterday, and it's at the closest hotel to the venue. The venue, by the way, it's in College Station. Sorry. Jeremy just plugged it. Yeah, we're in College Station. Sorry. Yeah, right. We're at the closest hotel to the venue, which is nice. And it's actually really good.
Your time's up.
Playing you out? Yeah. I turned it off again. Anyway, yeah, let me know if you have any. What's up? No. Are we still talking about Aggies?
No.
Because we shouldn't. Anyway, all right, I'm done.
All right, cool. Thanks, Jeremy. Also, if you parked in the lot downstairs, I have some validation tags if you need to get cheaper parking. So just find me, or raise your hand right now and I'll give them to you. All right, that kind of sucks. I was expecting one person. This is work. All right, you had your hand up, right?
Throw it out there.
This one. Oh. Who else? Put their hands up. All right. Nobody else parks? Everybody else walks? Cool. Well, today our We have Josh Marshall, who's going to talk about webRTC, all the fun stuff you can do with real-time communications. So I'll let Josh take it away.
Okay. Yeah, so I'm going to talk about webRTC real fast. My name is Josh Marshall, for those of you who don't know me. I work at UStudio. It's we do video management for enterprise companies. So webRTC is interesting for us. We don't have anything productized around webRTC today, but it's a very interesting area for us, which you'll see why in a little bit. But also, as I was kind of sitting back, asking myself why I was so excited about webRTC, why I generally get excited about some of these pieces of web tech. I like the pieces of tech that move to the browser that enable broader communication. When WebSockets came out and they sort of helped make a lot of the long polling and other things more, well, just a lot easier to work with and a number of things. I was really excited about that, and so I dove in. And WebRTC I see as a lot of the same. It helps us to communicate a little better in a little different way. So I get excited about those things. So I don't work on the implementations of anything. I really am just an enthusiast. I enjoy it, and I do imagine that we'll get in deeper, but I've been working with it now for close to a year and increasing, playing around this. So take everything I say with a grain of salt. All right, so a few caveats. This is a discussion about WebRTC. There's not a lot of Python here. I do have a Python server, and I'm going to talk a little bit about where you inject Python into the different workflows, because it is web. But this is more about web tech than it is about Python specifically. It should enable the things you're building with Python. You might hear me say a couple times, this is fun but not very useful, which is, a lot of the demos that you see and that you can come up with and play with early. They are, here's some cool things, play with some of the different aspects of WebRTC, but you're not necessarily seeing, okay, this is the immediate business value of this application. So I think that's fun, but again, some of the things I'm going to show you aren't overly useful, they're just kind of fun. And then I'm doing most of my examples with localhost. It solves some of the things that you can just spend a little more time debugging when you actually have it distributed across a number of network connections. So there's some things here that I'm getting around that when you actually go and implement it yourself, you're going to spend a little more time pulling your hair out on connections and things. But that's that. So this is also sort of WebRTC. Everybody's seen this picture, but this actually talks about WebRTC pretty closely to me. You see all these really nice demos. They're like, hey, in 5 minutes you can be up and running with a video player in your browser that's using the web camera. And I'm going to continue in that trend. But then pretty quickly you hit a wall where things aren't working and you have to dig into about 15 different RFCs, and you're not really sure why browser incompatibility is like 1998. But that's the nature of some of the early tech. So what I'm going to be mostly talking about is step one, sort of early ideas here, and I'm going to point out, hey, this is going to get fun for you later, but I'm not going to try to solve them for you. Yeah, and as an intro to that, as a little segue, I'll start with a sad story that's macro of the overall WebRTC experience. This afternoon, like an idiot, I was trying to enable one of my demos with this camera here, this Logitech camera, and I decided to install Logitech drivers because this wasn't working. So if all of you have seen that XKCD comic where he's sitting out on like the island trying to fend off sharks at the end of it when he just wanted to install FreeBSD at the beginning, that's kind of what it ended up with. So now I have a broken demo because of that. So it'll be fun. I'll still show it to you guys, but that's sort of a WebRTC in a nutshell. So here's, when we talk about what is WebRTC, here's the tagline on the website. And this is, nice. It's a pretty vague description, but that's in general short. We're now enabling real-time communication via JavaScript APIs for the most part, although WebRTC actually gets much bigger than that, and I can talk about that in a minute. But that doesn't really help you understand what does real-time communications mean. I'm not working with telepresence systems. I'm not working in maybe some of the areas that people automatically understand that. So help me make it more, or help it make more sense for me. So this is my interpretation that I kind of layer on top. WebRTC is more than this, but it's easy to come at it and look at it with these two main points. You get access to media devices inside your browser, so things like cameras and audio devices, and ultimately screen sharing and even other hardware that you can plug into it. And then you put that on top of a layer of peer-to-peer communication. So now not talking necessarily to a central server, but talking to other clients, which makes a number of things more optimized, enables workflows you couldn't do before, all that stuff. So that's kind of where I'm going to focus, and I'm going to go into it in that order. Yeah. Another point about WebRTC, it is actually a really, really important point about WebRTC and what's pushing the community and a lot of the things that they're trying to enable, is that a lot of the underlying tech of WebRTC and a lot of web tech in general, it's not that it's not things you couldn't do before, right? They're not putting things in the browser that you could not ever do, and they're making this brand new thing available to you. If you wanted to do peer-to-peer communication, guess what? You've been able to do that for a long, long time. You had to roll a lot of the stuff yourself. In fact, a lot of the exact same standards they implement inside of the browser, you would have had to roll your own. Some of those have been around 20, 30 years. Well, maybe not quite 30, but they've been around for a really long time, used in existing systems. So you're going to pretty easily be able to say, well, yeah, I could already do that, right? Flash had RTM FP for a while, which is peer-to-peer, and everybody knows that from such great apps as Chat Roulette, right? That used peer-to-peer and media devices in a similar way as WebRTC. A lot of the video conferencing stuff was, again, the standards that are being implemented even in the browser have been around for a long time. So you can go through all aspects of it and say, I've seen that before, I can do that. Really, what you want to step back and acknowledge in the course of this is that browser tech doesn't necessarily have to go out and do something nobody's ever done before. All it has to do is make those tools available to a broader audience and enable people to build it in, the most widely distributed application environment we have. So that's how I look at it, and I actually like that they went and took a lot of existing tech and incorporated into it. But it does complicate things. So when we start talking about what is WebRTC, there's 4-ish main JavaScript calls that summarize the overall workflow, and I'm going to go into each one and describe what they do. And get user media, RTC peer connection, all this kind of stuff. A higher level of looking at those things is user media is devices, cameras, audio, capture devices, etc. RTC peer connection is connections and all of the stuff that's attached to that, including using a method of handshake to determine what your computer is capable of, what my computer is capable of, and let's settle on some things. And then finally routing. So for anybody who's worked with NAT traversal and that kind of stuff, it's nice to just have that all baked in the browser for you, even if it does get a little weird sometimes. So I'm going to start with devices. Devices are also the most visual and most fun. But starting with a device, you are inside the JavaScript. You open up a constraints object, which is just a plain old JavaScript object, and you pass it into navigator.getUserMedia with standard success callback and failure callback. And of course, because WebRTC is very early, everything's prefixed and there are slightly different interfaces, and everybody's arguing about the different lower level protocols in some instances. We've already got deprecated protocols in WebRTC. They're the only implementation in some browsers, so it gets fun. But the constraints object is where you identify what you would like to happen. This is much like several other HTML5 standards. This is like, can you please give me something like this? I appreciate it, but I understand if you can't. That's kind of your constraints contract here. So when I say min width 1280, min height 720, maybe that's what I'll get back, if the camera supports that. And you see this is under video and mandatory. There's actually an optional too. And one is just a little more, I guess, asks a little harder, but it's still, you're not necessarily going to get it. And then there's other parameters in there like frame rates and other things depending on the device that you're asking for. And then another important item here is the source ID. So I'll get into that a little bit later. But the ability to say I've got multiple video devices, and if you haven't jacked up the drivers on your system, you can ask for specific cameras, or specific audio devices. So once you've taken that constraints object and you've passed it into get user media, the success callback. You then need to create a object URL, so blob URLs and data URLs and all that kind of stuff, depending on what you're producing here. And then you pass it into the appropriate playback mechanism. So here I'm going to be doing a lot of video work, but it could just as easily be an audio object, if or audio element, if all you're doing is pulling up the microphone. So I will go over to this demo, which is already up and running. It's a little small. So first off, it's already asked for permission, so we're going to restart that because this is a really important part of so you see here, I've got this big gray overlay with click allow. I'm going to start with that. The way that webRTC works is it asks you for permission as soon as you run that get user media. It says, okay, user, do you actually trust the site? And it's this little thin bar at the top, and if you don't do something like a big, hey, look up here, dummy, a lot of times they'll miss it and they won't know, and they'll just sit there waiting for your app to do something. So there's some things being done in Chrome and other browsers to allow you to make that more obvious. But right now, pretty much everybody you see in WebRTC has this big, like, click this here icon that goes in it. So once you say allow, then it's going to go in and take your constraints into its suggestion, as a suggestion, and try to get you something pretty close. So this is now, I've attached it to a video object, I'm getting playback, I've got it running through the, through my main camera here, and we're good to go. Now we can start doing other things with it. Or else I didn't say it at the beginning, but if I go too fast or I don't dig into some piece of the code that you want to see, I've got all this obviously running in the background live, so I can dig into it. It gets a little close to implementation in some cases, so I try to stay in the high level realm. But if you want me to dig into anything, just see anything a little more clear, yeah.
So this is all in the client, like just in the browser?
There's no server side here. Well, that's kind of a tiny bit of a lie. There's a Python simple HTTP module to serve the static files, and that's it. Over localhost, but otherwise everything is in the client. Now I'm not doing any communication here. I'm not doing any network communication yet. That gets fun. There's definitely some server-side components required for that before you get to the actual peer-to-peer. But this example right here is entirely client, no external services. So, all right, so that's demo 1. And so now one of the real benefits is when you start layering on the all the different pieces of different HTML5 specifications, like the HTML5 video API and the canvas element and getting image data and all that kind of stuff. You can start digging in and changing the signal and augmenting it all the way in and all the way out. So in this case here, I'm grabbing a has anybody used Canvas to sort of extract information from JPEGs and video elements? Okay, a couple people. So this is one of the ways you can do it. I've got a simpler version that I'll show you in just a second. But here I'm creating this swap canvas, and every frame of video, this actually runs. You can see the set timeout down here. This little chunk of code runs multiple times. I mean, every frame, however you want it to run, and it uses a swap canvas to put image data there, so that then you can extract the low-level RGB values and make it grayscale, or put someone else's face on it, or do any number of cool things. And then you've got here a different canvas, this out context, which is another canvas context, and you just shove the data there, and that's the viewable one. So you have this sort of hidden background canvas. So on that note, sorry. All right. So this is kind of a fun one. It's going to look exactly the same at first. But then you'll notice as the as the volume increases, I'm zooming in. So it's a really stupid thing, but we're supposed to have Skrillex up here. I forgot. Let's see if I can bring it back up. It's kind of fun, right? So this is webRTC. Wait for the bass to drop.
Put it next to the microphone up there to your ear.
Yeah, I mean, you can't go too high, right? You want it to. You got to slow build, right? Wait for the bass to drop. So anyway, that's kind of fun, right? And also nauseating. So let's get off of that. All right, so that's a very, very simple example. In fact, for that instance, I didn't even dig into the image data. That's pretty simple from just, as you can see here, you can say, grab this section of the video and apply it and slap that onto Canvas. So I'm just zooming in with an increased amplitude on the audio. But I'm using several different libraries there. I'm using the audio, HTML5 audio library and a couple of the things to processing nodes to go in and extract that data over a period of time. So give me 1,024 samples and average the amplitude, and that determines how far in I'm zooming out. So I'll still I can, if I have time, I can go in and dig to exact examples in the code. Yeah?
Sorry if this is getting too much into implementation, but did you get the microphone permissions to allow?
When you click allow, you're allowing the system to do what it wants with the constraints object it asked for, and that actually does different things in different browsers. So if I pulled that up in Firefox, which presumes I wrote it in a cross-browser way, I'm not going to promise I did that for that particular example, Firefox actually then pulls down this drop-down where you can pick which video camera you want or which audio device you want. Chrome, you set those defaults, and then it just sticks there. And then I'll show you an example. My broken demo actually gives you a way of selecting individual sources when it sees those. So anyway, yeah, so here I was using an audio context and a couple of other things to, did that answer the question? Okay. I was using a couple different pieces of libraries, but you can imagine, you go hog wild. I don't have I forgot to bring my example. I've got this little chat client which actually uses the media device, and that's it, to grab a screenshot of you as a live avatar. So every 10 seconds, right? It's just grabbing it, resizing it, and shipping it off down WebSockets. So there's no peer-to-peer communication used in that, and you just get this nice little, live avatar showing the person is real while you're chatting or whatever. So that's an example of where you could use the media devices by themselves. Is
that what Google Hangout does?
So that's interesting. Google Hangout just recently moved to entirely to webRTC. They were using plugins and some other things beforehand. So I'll get into it, but when you start talking about Google Hangout level, that's when it gets to just draw the rest of the owl. It gets really complicated, how they're doing that and how they manage, one or two people over webRTC call. That's the fun, easy demos, right? Oh, here you go. It's like run these 5 lines of JavaScript. But then once you say I want 40 people on the call, that's when you've got to have external servers that do it. And so whether the processing is on the server or it's making it in client, I'm assuming here you mean like the little hat that you could put on in Google Hangouts and that stuff. Yeah, that compositing could be on the server side, because remember they're doing a lot of compositing in some of those cases. You've got all of the individual videos at the bottom. You've got some other elements like volume and other stuff that they layer over. So they're probably all over the place where they're doing the compositing for it. But yeah, that is something that is capable of being run with. All right, so I already showed demo 2. Now I'm going to show you my broken one, just because I spent so much time on it, even though it doesn't work. So this one, you can see I have a separate camera up here. My intention with this one was, oh God, I gotta get away from that one. So I wanted to do a anaglyph version. Is anybody familiar with anaglyph? What it is? So that's just the fancy term for the red, blue 3D, or red cyan, technically. So here you can see that I'm using a different set of APIs, the media source track, get sources, which is only in Chrome, and I don't think it's nearly along the path to ratify, but they've rolled it out so you can do it. Nobody else has this mechanism, but because they don't give you the drop-down inside the allow, like you were asking, this is another mechanism. So I can say, okay, give me source 1. So now you guys can't see it, but there's a little green light here. I click source 2. My demo doesn't work because of driver issues, but what's supposed to happen here is you will be seeing the red channel here, and the blue channel is it's getting dropped out because the browser is not being able to see the camera for some reason. In fact, if I wanted to do it another way, I could show you now my Logitech camera is coming on, and it's this one, and it's still getting confused. So it's only doing one of them. If you all could have come to my office earlier today, you would have seen it working. And I actually have a bag full of now useless 3D glasses. I bought like $10 worth of really cheap 3D glasses. So I can give them all out and we can all look at the left channel. That'd be fun. So anyway, true stories from webRTC friends. All right. So anyway, that's playing with media devices. And I think that's probably the most approachable stuff, right? It's entirely client-side at this point. You're just interacting with devices, and assuming you don't screw up your drivers, it's kind of fun because you can stack these other pieces together. Now you notice I stayed mostly in Chrome. That's because, again, some of these APIs are only in Chrome, and they've all got the prefixes and all that stuff. So again, once we come full circle, any of these examples you want me to dig into, just pop the JavaScript up on the screen. It's not pretty productized code, but I can show it to you. We can go through each example in more detail if we have time. But there's a lot of stuff here that I want to cover. So you can also go the other way and say we're bored out of our mind, just stop now, if we get to that point. All right, so talking about getting into multiplayer. Now, we've got these media devices. So like I said, you've got the two pieces and then you can combine them together. Now we're gonna talk about peer-to-peer connections. So move media sources aside, we're not gonna bring this back around for a second. And we're gonna talk just about opening data connections to other devices. So, hey, it's as simple as one line. Not really, but we're gonna start with this RTC peer connection object. And much like you passed in a set of constraints to the media devices, and you said, let me know when it's ready, and then you're able to start working with it. Peer connection is the same, except a lot more involved. So, again, who has messed with NAT traversal and ice and stun and turn and all those things? Okay, so we're going to get into some fun here. As a caveat, I'm going to describe some of the lower level stuff. For the most part, all you need to know is I need to point to a server of this kind and cross my fingers and it will all work. But I'm going to go into the full detail because I think it's good to know, especially when you're trying to diagnose something or you're trying to determine what requires external services or where you're in the process, because you will hit little speed bumps when you're working with this. But high level peer connections, the little object I constructed there, are not useful until we've done a series of steps. We've negotiated the different addresses that we're able to talk over, your device and my device, and I'll get into that in a second. We share that handshake like I talked about to say, what's your device capable of, what's my device capable of, can we actually have a conversation? And then you attach the things that you want to send data over. So you saw me playing around with video streams. I can take that and say, okay, use this video stream and send that over the network. Or we can do data channels, which is probably what I'll spend most of my time talking about next. But you have to add those things before you have this wholly working beast. So when we start talking about this, there's a lot of acronyms that I'm going to anything, but when we talk about NAT, it's network address traversal. It's just around this concept of there's a limited number of IPv4 addresses, but we've gotten really, really good at working around that, so we're never going to go to IPv6. And we now have to work in this environment that requires a lot more acronyms just for me to talk to your box. So I said that twice. There's not a lot of interface yet, but again, if you get lost in the details or I go too deep, don't worry too much about it. And I say go too deep, you can go down the rabbit hole further if you want. So we have this is where we start bringing in external servers. So we've got this stun turn set of servers out in the public internet, which I'll talk about in a second. And then we've got two clients, right? And they're wanting to talk to each other. These red lines here are not proper network diagrams, but they're identifying that there's a wall there, right? So it could be an internal firewall at a company, it could just be your router at home, but these two obviously cannot address each other directly through the IP addresses, because the only IP addresses that the browser is aware of at the moment is the loopback and the, well, not loopback, but local IP addresses here that it can communicate on. And anytime I'm doing my localhost demos, by the way, this is a cheat that I'm talking about. I'm just using these addresses, so it makes it pretty simple. But in order to talk to the other person, we've got to punch through whatever NAT services. We've got to provide the right IP addresses. So over a long period of time, they developed a set of standards for this, and it's called, the main one that's being used is called ICE. And so it uses stun and turn and a set of session description protocols and all that kind of stuff to relay the optimum IP addresses to use, right? So in the stun world, I'm talking to a stun server and I'm saying, hey, just give me the external representation. It's just like you go in your browser and saying, what is my IP.com? And you get your IP address and then you send it over to somebody. This is doing that for you. That's all it's doing, is delivering that IP address for you. With the intent now that with a stun address, I'm able to try to punch through the router with a couple different methods. A turn server is actually just a proxy, right? It's a big fancy way of saying all packets get routed through a turn server. When you're talking about P2P, especially if you're talking about from optimized sense or a data security sense, turn kind of seems to defeat the purpose. But if you want to provide full fallback for just a lot of the weird wonky network configurations out there, you're probably going to have to support turn, and some portion of your users are going to be sending all their traffic through an intermediary box. Now it's still encrypted and other things, but there's that. So at the end of this, I have a set of IP addresses or ICE candidates that I'm producing, that the other client is producing, and then again, that's stun is simple traversal user datagram, turn is traversal using relay network, session initiation protocol is the text that I'm shipping back and forth to say this is the kind of stuff I want to expose, and these are the ports and all that kind of stuff. And anyway, there's a couple of pieces there. It's only really important because when you start constructing these peer connections, you need to provide a set of servers. So here I'm providing ICE servers. I've got a stun server and I've got a turn server. And you can provide credentials as part of this, or a number of different things. But at the end of this, the peer connection object is just hanging onto those servers and saying, all right, as soon as we start talking for real about negotiating around services and what I want to expose and send out to the other folks that I'm being connected to, I'm going to start using these to determine the right IP address to send out. And different browsers use them slightly differently, but they all follow ICE and the specifications. They just use them at different times. So down here, you see that when we get an ICE candidate, here's a JavaScript event method that we're listening for. So whenever somebody reports an ICE candidate locally, when I get it from a stun server or turn server, then I'm going to ship that off to the other guy. Or when they send me an ICE candidate, I'm going to apply it. Now, hopefully what you heard right there is, wait a minute, we don't have a data connection yet. How are you telling me about an ICE candidate? How am I telling you about an ICE candidate? We don't have an open connection, right? And so this is where the Python part comes in. So pay attention because you'll miss it. It's like one slide. And yeah, this is in the signaling. So signaling is sort of the wild, wild west of webRTC. There is no specification. They've done it that way on purpose. So however you want to communicate this handshake, right? You've got a set of text protocols that you've got to, hey, here's all the stuff I'm capable of doing on these IP addresses, on these ports, and I've got to figure out how to get it to that other person. So I could do it over just a big Django REST API if I wanted to. Hey, hit this endpoint, and he over there, he's going to be polling the server. You could do it over WebSockets. You could do it over email or IM, actually. I mean, there's nothing that stops you from pulling the server out and just finding another mechanism for sending that. But Signal is important because that's the mechanism you're going to use to authenticate your users, who's allowed to talk to each other, what are they allowed to do, the services they're allowed to access, all the standard stuff that you do on a daily basis, but now you're putting that layer around the communication. So I have a little Tornado server that I'm using for my WebSockets, because everything I do is Tornado. It's my golden hammer. And the WebSocket layer is very light and really abstract. I just pretty much say anything that comes down the line, if it's not coming from, I will send it to every other person who's connected, other than the person who asked me. That was a really bad way of describing it, but it's just a broadcast service. So I don't even get in the middle of the message. And that's maybe all you need. I'm not putting any authentication around it. But so now we're going to go through the full workflow of, I am interested in talking to Joe, right? I have whatever service, right? Whether it's a Django service or IRC or whatever, I've discovered that Joe is out there and ready to talk to me. And so I've got to say, here you go, here are the things I'm willing to send to you. Video services, data channels, whatever. All the different things that I want to talk via. And I send that over signaling. That goes down the other side, so through the Python server, still in the signaling realm, there you construct an answer, and I'll show you what the JavaScript calls for this look like in a second. You construct an answer based on that input. You say, cool, I'm interested in sending you these services, I'm interested in receiving these services like this. Here you go, that gets bounced back to me. Then once I receive the answer, now we're starting to run through ICE candidates and say, okay, well, here, try this IP address, and does this work? And hopefully we can settle on something around stun or even internal network before we have to rely on a turn server. But all of that is now happening, and that dance happens pretty quickly. And at the end of it, we should both have a set of candidates, one that works well, and that's the one we're going to lean on, and we're able to now open the connection and start sending data, and hopefully punch through the NAT if that's the, yeah.
So how do you know who Joe is to begin with?
That's all up to your app. So when, like I said, I've got a WebSocket service, so I'll show you in a second. The client will, the first thing that my little JavaScript does is it opens up a WebSocket connection, and it says, hey, I'm here, let me know when somebody else joins. And so then Joe opens up his laptop, connects, he sends a WebSocket, so still going out to our main signaling server, and it says, I'm ready, I see that, and in my stuff it's fairly naive. I assume that anyone who connects is the only person I'm going to talk to, and just start doing the handshake. But over time, I mean, that obviously doesn't grow to multi-point conversations and such, but that mechanism, the signaling of who's available, who can I talk to, who's interested in talking to me, what are the authentication requirements, because just because somebody joins, I might not be allowed to talk to them, depending on your business application. All of that stuff is the responsibility of the signaling server. And there are a lot of libraries that'll help you. There's, honestly, on the Python side, I think we're probably a little light compared to some things like Node, and Node has any number of, spin up this Socket.io based, signaling server, and it works. So we should fix that on the Python side, which maybe I should do by spending more time than one slide talking about Python. This is what it looks like, still simplified, from the I'm generating an offer. So I'm the instigator, right? I see Joe, I want to talk to Joe. Here you go. I'm going to construct this new RTC peer connection, which everybody, both the person receiving the offer and the person creating the offer, have to create this peer connection with a set of ICE servers, like you said, like you saw earlier. And there's actually other parameters that are allowed, constraints, the different types of network requirements you want to put on it. I won't go too much into that, but there's a lot under the covers there. After we have this connection object, I create an offer. This is using SDP, and I'll show you in a second, and then you'll not ever care again because SDP is really, really gross. But I create this session description, which I set locally, and then once it's set locally, I pass it off via signaling. Hey, here's a bunch of text that describes my services. Then I wait. I wait on the signaling server, which is again why event-based services are pretty good for this, because I can just hang on to a WebSocket connection. But I wait for Joe to sit there, look through the contents, and then ship me back an answer. And then assuming all that works, I set the remote description, and like I said, now we're off to the races, trying to determine what IP addresses we connect over and all that, and then we settle into a good solid connection, and that's when we actually get to start doing application logic. So this is the answer side, which is, you notice the only real area that changes is that middle section there. So here, instead of, if you're the answer, not the instigator, I believe that's the technical term for it, but you are just waiting on the signal, and then as soon as it comes in, you set the remote description first, you generate an answer, and you send that over the signal. So instigator creates an offer and sends that, and waits for an answer. The recipient waits for an offer and sends an answer. That's it, high level. You can see everything else. They're both waiting for ICE candidates in the exact same way and adding them. That is opening one connection to one person. So you're going to need to do that with every single connection that you want to have. So when you have 4 people in a call, if you want to have all 4 of them talking to each other and sending video or arbitrary data or whatever, you're going to have to do that dance for each individual person, which is when we get into the server conversations and other things to help later on. So any questions there before I do a quick demo around that? Yes?
Are you going to show the Python?
Yes, I will show the Python. Python's really simple. So, I mean, definitely everybody. All right. Oh, I have more content here. I don't care. I'm going to go to the demo. All right. So, first off, I'm going to start with actual Python. Yay. So this is a bad practice already out the gate. We're keeping track of all our users in this one process. So this is a very resilient application right here. Makes it simple for this. So all I'm doing, if you don't know Tornado, they have this nice little WebSocket handler that you attach to an application server. When I open, I'm going to generate a unique ID. I'm going to populate that user's dictionary with that ID and the handler, because that's what Tornado uses to send out a message. And then I'm going to immediately write a message to the client who connected, right? Here you go, here's the user ID that you're going to be using. Keep that in mind. It actually doesn't matter so much for my application. It helps in debugging, but when you're doing one-to-one, it's like okay, you're 0 and you're 1, I don't care, right? As it grows, you're going to want to keep track of those IDs for, again, permissioning and all the other cool stuff that you want to do. So in Tornado, this on message thing is anytime a client sends in a message, this is what you write to intercept that message and do things with it. So you can think of each instantiation of this event handler as one direct connection with a client device. So here I'm saying, I'm assuming all messages are JSON, and this will 500 in a really pretty way if it's not. And then I am printing it so that you guys can see what's happening in the handshake or the signaling server in a second. But then I'm just broadcasting to everybody except the person who sent the original message. That's just so you don't get some recursive problems. Anyway, and then anybody who, if I get any exception trying to write to somebody, I'm presuming here that means their connection died. They closed their computer, they were not nice when they left, or there's some other problem. So I'm just pulling them out from the users list to simplify. You will want to do a whole lot more than that when you do a real application. But and so I do the same thing here if it's an explicit close. So then here I have the most simple handler you can have in Tornado. Is that big enough? Actually, I didn't even ask. Can anybody see that?
No.
Okay.
It's small.
There we go. So this is just a plain old HTTP handler or WebSocket handler, and I'm saying, hey, render the this template, and I don't have anything really I'm passing in here. You obviously would pass in authentication parameters or cookies or whatever you needed to there to determine what they're allowed to see. And then this gets into just Tornado internals. The main point here is that /events is my WebSocket handler, and / is my index. So let's get over that. Any questions on the Python side?
What exactly are you passing to the clients to inform them of the other user? Just the UUID?
So in this case, I'm doing no interception of messages at all. So all of the logic lives on the client. The client is saying, and I'll show you that in just a second, but he's saying, I'm announcing myself. User.announce is a method that I'm pitching off, and here's my parameters. And so the Python server here is just taking any message it gets and happily passing it off to every other participant, right? It makes for a really simple do anything sort of demo server, but that's what I was saying is you're going to want to implement your own business logic there, right? Are these two people able to talk? What are they talking about? What are the resources they're trying to access? All of that's up to you, and you'll need to build that. Some of that will be server-side awareness while you're signaling, and some of that will be up to the client. So if you just keep in mind that this WebSocket server now is passing everything it receives out to all customers, then when I go into this, yeah, so I've got this really simple method tree here, and so I'm just taking any method and using a dictionary access. So when an end client says, hey, I've changed my name, I'm going to use user.name as the method, and then I'm going to just pass all of the arguments from my client system through the WebSocket server back down to the other client. He's going to call this function, so hopefully he provided the right parameters, and then we're going to execute it. And this is a chat server to explain that. So a user can change their name, they can announce themselves, they can do all different things here. And so this is I'm just putting all logic on the client side. So, all right. So that's the WebSocket side of things, and I can dig into that if anybody needs me to. But I was going to go ahead and move into the actual connection pieces. Let's see if I have any questions on the socket side. Okay. So. So just so you guys can see what's going on here. That is totally broken. That's demo number 2. I'm going to try this again. Should be cached. But... Nope. I've lost some code. Darn it. Well, I'll walk through this code. I'm not sure why it's not working. what I'm trying to do here is, that's an old UI, so I might just have lost a change in an HTML file or something. But here I'm using the pieces that I was talking about, right? The peer connection, the session description, and the ICE candidate. And I am, as soon as I get that WebSocket request, right? So in this chat server you connect, and if the UI was showing, it would say, all right, negotiating is what pops up in the text box. And I'm sending out an announcement over WebSocket, that user.announce that you saw, and I'm saying, okay, I'm here, I'm ready to roll. Let me know when somebody else comes here, and that's got a user ID and all that kind of stuff. Then somebody else joins, and they see that I see them announce themselves. So now I'm the person who's already in the room. I am the initiator, and I'm going to send you that offer. And this is what I was talking about. And I've got a few little helpers here, but I'm creating a connection object, and I'm creating a data channel, because that's what I'm using here. In a chat room, I'm not using the media servers, the media sources. And I create that offer. In the callback here, like I was showing you earlier, I set the local description, and then I send over the WebSocket with this little send socket line here. I'm saying, here's the method, user.offer, and here are my arguments. And so on the other side, this is just going to go right through the WebSocket server and out the other side to so here you can see, you can now see the parallel, right? This is just going straight through the WebSocket server. It's a pass-through, and that method, user.offer, is getting called with a user ID and an offer SDP. That's the session description protocol. So that's just a big bunch of text that identifies the capabilities of my system. So it's a pass-through here. I don't care about the internals. I don't have to mess with the internals of the SDP. I just get that, and I pitch it over the signaling server. And then on the other side, I receive it, and in here, if we come back down here, receive offer. So here you can see that inside user.offer, I'm receiving it. I create this RTC session description object with that offer, and I say it is an offer, and here's the text. And then I'm creating another connection. This is now on the recipient side, and the RTC peer connection on that side. And I am setting that remote description, and then in send answer, I'm creating an answer, sending that over the signaling server, which now we're in here, user.answer, receive answer on the other side. Does all that make sense? It's a lot of back and forth, but it goes back to the drawings, maybe even more helpful than the demo would have been anyway. So I'm sending the offer, going through WebSocket handler, receiving the offer on the other side, creating an answer, sending that back through signaling. I'm receiving the answer on the other client, and now we're ready to go. I've got a local description and a remote description on both sides. So now we just need to generate IP addresses. So going back over to this, that's actually a little more implicit in the system. So ICE connection, candidate. So when I create this connection object, which is called for both sides of it, if you remember, I'm saying on ICE connection, whenever an ICE candidate is found, run this this callback function, and that ICE candidate. This takes the candidate from the event that is passed into the callback, and then passes a couple of important pieces of information from that. Again, you don't care about the internals of that. You just need to extract a couple pieces of information, send them via the signaling server, here the WebSocket server. And then on the other side, so send ICE candidate here, that's using, again, my socket. It's using user.ice is the little method name I've given it, with a set of information. And here you can see on the other side, I receive it, receive ICE candidate, just adds it calls on the connection. It does this business. So it takes those important pieces of information and says, okay, thanks. I now have an ICE candidate for the other person in this conversation, and I might do this 16 times, depending on how many different IP addresses and services it's making available. At the end of it, though, as it's receiving these ICE candidates, it's trying them out. They're both trying out each other, right? So simultaneously, they're both saying, give me some ICE candidates. As I'm pulling them down, cool. Start pitching them over the signaling service. trying them out, and at some point we're both talking over the same one, cool, we're good to go. And we've got an open conversation. And then, I mean, that's pretty much it from the connection side of things. But like I said way back when, now that we've got a connection working, we've got IP addresses and an open conversation, what are we saying? That was actually determined throughout the course of this, whether you're going with media streams and sending video information or audio information, or you're using data channels to send arbitrary data. Let's see. Data channel. So in this particular instance, instead of saying on add stream, which is one callback, that's one way of saying, here you go, I'm offering video. So on the recipient, I can have an on stream callback and say, cool, take the video stream, pipe it to this video object, just like you saw me do a minute ago. In this case, I'm doing on data channel. So I get this channel object from the callback, and the channel object works a lot like WebSockets or anything else. Now I can just start sending arbitrary messages. So I'm really sad that that's not, looks all right. I'm just not really sure why. Let's see if Firefox likes it more. I don't know why it would be showing the different. Oh, it's just there. It's bizarre. Okay.
Try it on Firefox.
Yeah, this was. Oh,
That's
good call. Yeah, so this is like an old version, which is really weird because I'm showing you the code from the new version. So I might have copied some things back and forth incorrectly. So that's data channels. I really wanted to show you the. I mean, it's a really simple. You can already see what it's supposed to be, right? It's supposed to be just like a little test server, but a little test chat server, but it's not. It's even the wrong thing. Okay. Anyway, so coming back to the overall, are there any questions about the handshakes, all the different pieces in that? Yeah.
So to get the IP addresses, like each client has to communicate with another group. Like, so there has to be like one of the clients has to communicate with each of the other clients.
Yeah, if you want to do it that way, and I'll talk about network topologies in a second, like you're deciding how you want all of your individual clients to talk. And when you're doing one-to-one, that's what makes the most sense, right? I'm going to open a connection to you, you're returning and opening a connection back to me, and we're sending data back and forth. And we're using a set of external servers, an external signaling server, which is the Python implementation here, and a external set of stun and turn and other things to determine the IP addresses. And there's actually, if you saw in my construction, I'm using, Google's got just a free stun server to use. Nobody would do that with turn because all data is passing through there, right? So they don't want to be responsible for that. But yes, once you start talking about multiple connections, now you've got to do that for each individual user, and you've got to manage on your side, inside the JavaScript code, who's talking to who, and connections appearing and disappearing, and getting upgraded, and moving between networks, and all that kind of fun stuff. Yeah?
Where do you see the next innovation in this space as far as how the...
Really, I think there's a lot of opportunity here because most of the kind of things that people are talking about are what I'm doing here. Hey, here's a cool little video player, right, that's using my camera. Hey, here's a data channel and I can send arbitrary data back and forth. Now go do something with it. Now, so there's a big set of existing players in the video conferencing industry, whatever, and some new startups that are playing in that realm. And I'll talk about them in a couple of the interesting ones there in a second. So you can see that there's some disruption there. Okay, now I can choose a $100,000 Cisco telepresence installation, which has a lot of benefits there. Or I can start trying to put it into my web browsers and in devices. Well, you can tell for a remote-based team, right, that may be a lot more cost-effective and just a lot better if now I can have mobile applications using RTC and my home browsers, and I don't have to worry about have I installed all the right infrastructure. You add one more layer on top of that, and there's the, okay, I'm talking to those existing systems, and I'm talking to the new systems, right? So there's definitely some vendors coming out who are talking to both the old existing infrastructure, and a lot of the standards are the same. That's some of the benefit of WebRTC. It's some of the same mechanisms they use to communicate can, with a little massaging, be used with existing infrastructure. And then talking to WebRTC, well, now I've made both systems work. So that's sort of the easy wins to go after, right? Disrupting in video conferencing and add-on services into video conferencing, but creating these sort of new web browser-based and mobile application-based collaboration environments. For me, and that gets, I don't know if I'm quite there yet. Yeah, so I can skip a little bit of this. I don't know what time it is here. There are tons of examples and services, and I'll point out a couple that are based on the video and audio. Just simple, hey, it's a video call, or it's a small video conference call. Lots and lots of people doing that. To me, I think that the data channels are really the breakout feature here, because when you start talking, first off, I didn't really go through the slide here, but everything is encrypted, right? So it's got, the different protocols underneath the covers are slightly different, especially depending on which browser, which version, all that kind of stuff, but they're settling in on the important standards here. And all that content that passes peer-to-peer is encrypted. And if you're not going through a turn server, or your application isn't designed to pass the data through a central server for other reasons, which I'll talk about, it's peer-to-peer. It's not, I'm building up these dynamic networks. So there's a lot of opportunity there. You can immediately, my head goes to things like, and there's people who've started building applications like BitTorrent in the web browser. Share legal files, kids, but the application there, right, of being able to say, all right, arbitrarily file transfers now. I can just spin up a network and it's encrypted, sharing private documents back and forth, and I don't have to worry about going through a central server or being able to be tracked. You can go one more step and say, hey, we're going to go build a Tor network in browser, right?
So yeah, how does it do the encryption? Like with browser is it?
Well, it's all standardizing on TLS around the packets, the different types of packets they're going to send. So we use SCTP for data channels, and we use SRTP for.
So you have to have like some sort of shared secret of some sort. Or something.
Yeah, and that's in the browser implementation. So they handle all of that. In fact, based on the different protocols they've played with, right? Whether the secret is in the SDP handshake, or whether you've got different applications that pull it out and they make it so you don't even have to share that secret. That's what they're leaning towards with some of the DTLS SRTP and the DTLS SCTP. But you've got some options there for encryption, but the mandatory to implement is that you are using encryption, and they are standardizing on these systems. So the browser does it. The browser has to be according to spec, right? So that's the nice thing, is it's just baked into the protocol, and you shouldn't have to worry about it. You didn't see me passing around a lot of custom, I want to use DTLS in this case, right? It just happens. There are a few parameters for backwards compatibility for data channels, because Firefox used SRTP for a little while, but now it's coming up to the SCTP side of things. But separating out from the actual protocols underneath the covers, it's all encrypted. It's point to point. So you take applications like BitTorrent, like Tor, like when you talk about people in countries where they don't trust their ISPs or such, now you've got an opportunity to build up a communication network, potentially. You still got the signaling server you've got to solve, so maybe we're moving that to SneakerNet or something, but there are opportunities there of moving information around without having to go to central servers that can be shut down. And it's in everybody's web browser, right? That's the long-term goal. So
that probably ties into Bitcoin as well in many ways.
Sure, yeah. My head just went to Bitcoin mining in the browser, and that was funny. Yeah, you can definitely be sharing those credentials and sharing pieces of information somewhat with some level of security. You do have to be aware of your signaling servers and the touch points there, and who's allowed to communicate and controlling all that. But there's some really cool applications, I think. The innovation is still giving out the tools to web developers like us, and us sitting back and saying, how can we apply it to our business applications? I think that's the thing that excites me most about WebRTC, and specifically data channels. I deal with video on a daily basis, so video excites me. The different applications of video I'm moving through. I see any number of opportunities there, but I think for most people who aren't dealing with video on a daily basis, that is cool. Video is cool. and you should always be thinking about visual communication and how you're incorporating that into your products. But the data channels may be a little bit closer to home with what you're working with on a day-to-day basis. So I'm going to talk really quickly through. Ooh, I've been going for a long time. Okay, like I mentioned a second ago, the network hierarchy is important when you're deciding. So everything we've been talking about up to this point has been the full mesh. Everybody is connected to each and every individual client, which completely falls over as soon as you're talking to 15 people, and you're sending out a single video stream to 15 people, and you're receiving 15 individual video streams or whatever it is. Right? That's going to fall over. So that's when you see a movement to, and in a lot of cases, you see this sort of star topology where everybody's talking to a central server, and that central server is doing the compositing and sending out one video signal to everybody, and that's where you see the large video with the little, small units composited inside the same video signal. So it's one stream going out to everybody. Ring you don't see a lot, but I think that's another cool application, right? If you start having these really, dynamically forming networks where you're sharing information and it's distributed across it, but you only have 4 people you're talking to, and that's all you know about, and you can put information into the network, and it gets where it needs to, and you can pull information out of it. That gets really cool. It's a little more complicated to go build, but I want somebody to go build like a Raft implementation in the browser, so now I can just have this shared, very transient database, right, that we're pitching as part of, or something. But anyway, so I was going to talk a little more about this, but don't worry about that. So coming around, Google Hangouts went to full WebRTC, HipChat. If anybody uses HipChat and you use the video call, you're actually using WebRTC. The Amazon Fire support, you remember when the Amazon Fire came out, everybody was talking about the ability to just hit a button and now I've got a video conversation with support. I don't think they've come out and said they're using WebRTC, but people have done packet sniffing on it and said, yeah, they're pretty much using WebRTC under the covers here. So that's interesting. And then there's a few little companies, Talkie.io. I'm not going to bring it up, but if you have time, that's the basic example of create a website, put my video stream on it, and send that website to somebody else, and they'll be able to participate in the video call, and we'll add people to it. They've got some cool open source projects there. Squiggle is a fun one. If you're doing a lot of remote work, I would suggest you kind of look at them. They've done a really good job of making the UI simple for, here's a dashboard of, sort of like what I was talking about a minute ago, the avatars that update once every 30 seconds or once a minute, but that's your team. So you can be working from a coffee shop or home or whatever, but you all have live web cameras and you're all sitting there working, but you want to talk to Sam. And so you go over and you say, I'm going to click on Sam, and immediately it opens the connection because you've already accepted all the permissions. So it's designed to be like poke your head around the cubicle or whatever and say, hey, let's chat. And then you decide we need to bring Jane into this conversation, so you click Jane, and now it's a 3-way conversation. They've done a really good job with the UI. So Peer CDN is another example of one that's doing some cool things. So everybody's talking about video conferencing for actually sending video data point to point, but what Peer CDN did, and they got picked up by Yahoo, they stepped back and said, we can use WebRTC for reducing the load on cache, right? So if I've got a video stream or static assets that are being shared by a lot of people, we can completely remove the cache for some portion of traffic because these two people are close together and they can send the content to each other, right? So now we're distributing the load. So there's some cool stuff like that. And there's a giant list of things that you can get into WebRTC deeper. And this is just some of the things that I imagine if you go start digging around, you'll get interested in some aspects of this. Maybe it's the standardization process and what they're talking about. Maybe it's building on mobile applications that leverage some of this stuff, and they're using the native client libraries and things, whatever. But there's a whole bunch of areas that you can go get excited about. I could share some of these, but these are just sort of 4 go-to URLs that talk about the industry and what people are doing with this tech and how-tos and some of that stuff, some code. So that's it. Are there any questions? Yeah.
So taking the point of the lazy application developer, there was a lot of talk about just the negotiation, the connection, just originating a connection between 2 peers. Is there anything out there that's abstracted that out so I can just...
Yeah, there's several.
I can deal with my application.
There's several layers. There's some good libraries out there. I tend to go to it from a here's how it works under the cover so everybody knows, and then yeah, if you can get a vendor to solve it, go do it. If you can get an open source library to solve it, go do it. And I think there's different layers there. There are vendors that will turnkey the whole thing for you. You want to use video and audio conferencing in these small conversations, here you go. Just hit a couple API endpoints, and that's all you have to worry about. Run this JavaScript on the client. And then there's middle grounds, right? There's people who do hosted stun and turn for you, and they give you a little JavaScript library that does that negotiation, but all the application logic, the sharing of video streams and data channels, that's still up to you. But the disconnect and connection, you don't have to worry about quite as much, and layers in between. So they're definitely people. And I should have put those in the lots of resources, but I mean, if you go dig around in any one of those websites, they'll say, oh, here you go, these guys are doing a good job, or here's some JavaScript client code, or here's a node, do it, just npm install and your app is built, right? So that's, yeah, that's libraries. Yes.
Can you put this all on GitHub?
Yes, I can. This is Keynote, so if you don't have Keynote, you won't be able to do it.
The code that doesn't work.
But I'll definitely put the code that doesn't work up there. I'm upset, but like the anaglyph one, I know why it's not working. I've worked my video drivers, but the chat one, it's like I copied a file wrong. It's why version control. It's a good idea.
Really good idea.
Yeah.
So my last question. Do you think that if you're releasing something mainstream today, I want to write an application, I want to get wide usage out there on the web, do I need to keep flags to fall back? Like in terms of browser support and things like that,
Yeah, I mean, it depends on what you're doing. I should put a caveat there. If you can push your users to certain browsers, but mobile support in this is real wonky. That's one of the areas here that I didn't talk about is browser compatibilities. It's all over the place. So let's see if I can just bring up. Is webRTC ready yet? So here they talk about, wow, internet. So first off, you see two giant offenders here. One, not surprising. One is pretty surprising. So, Chrome's got most of the pieces. They're the most out ahead of it. I mean, they're really strong supporters of webRTC, and there's some really, really good, healthy things that they're doing for the industry, and there's some things that they're personally interested in, like spreading VP8 adoption over H.264 and some other things, right, as far as video codecs.
First column there?
What's up?
It's Chrome, and then what's the other?
Canary, isn't that the early build?
Increase the font.
Oh, yeah. I can see it. So you're going to see in here, okay, there's a lot more APIs than you talked about, Josh. Well, a lot of these are early ideas or still in specification rounds, and some of these are features like echo cancellation inside. You can see some of these browsers don't support echo cancellation, which means you better be wearing headphones, because if we all start talking, it's going to get really bad really fast. Solid interoperability, I like how this is a feature, and nobody supports it. So good job there. Screen sharing, that's another fun one, right? Screen sharing, Chrome put out a feature that you had to, early as a beta, that you had to turn on in the flags in the browser, but then you could ask for it just like any other source, like a video camera or audio camera, and then they're pulling that back because they had some security concerns with, okay, now you can capture the screen, you've authorized it, anybody can capture the screen, and they can run arbitrary code if you've written your application poorly and control, and well, I mean, even if they're at that point, they can already run JavaScript on your system, and they can control your mouse cursor, and they can do other things. We're getting to a point where that could be really sketchy, right? Suddenly Bank of America gets the wrong JavaScript attached to it, and they're doing a screen share and being able to, anyway. So there's some concerns in some of these, but this gives you an idea of exactly how comfortable you can be with WebRTC, and that's not very. There are plugins for IE and Safari. There are a lot of shims and polyfills and other stuff that you can put together to produce something working, but it's still early days. Yep.
Are there libraries that would fall through to Flash? Sort of like
Yeah, I know there are a couple of them that have that RTMFP fallback, so it's peer-to-peer, and certainly Flash supports the device capture, has for a really long time. I don't remember any of the names off the top of my head, but I know that I've seen one or two recently. And I've even seen one or two, I don't know if they're open source or not, but the MCU, the control point servers, that's what's used when you have a conversation that exceeds the number of connections I want to keep up with. that's everybody talking to one server and then one stream coming back out. It does the compositing on the server. There are some servers that will do that fallback for you too, but they may all be vendors. Any other questions?
What does that say about Safari as a browser?
It's interesting. Well, here's one of the things that's really important as you look across this. I come to it from a video perspective, so that there's a big, take everything I say with a grain of salt. But Chrome has an agenda around, it's not an unhealthy agenda, but it's definitely an agenda. They've invested in a video company. They bought one. They've invested heavily in VP8. So is everybody aware of VP8, the video codec? Sort of like the open source video codec, the alternative to H.264. And they've been pushing it for a long time. And H.264 is just it's too much in the daily operation of most video applications and workflows and streaming and all that kind of stuff. But VP8 on the WebRTC side, now that's a new frontier, right? So they're pushing to make VP8 the mandatory codec in WebRTC. Whereas on the other side, you've got a group of people who want H.264 because they have existing patent investments and ownership and lots and lots of stuff there. So IE and Safari are in the H.264 world, right? And the Chrome also supports H.264, but it's the cheerleader for VP8 and VP9. And Firefox has supported that too as an open source codec, even though it's ultimately going to support H.264 for some other reasons. So there's a war being waged for the codecs and patents and ownership of some of that stuff that's going across the line. So I think that probably plays into a little bit about the hesitancy around Safari and IE, because right now most of the work is in the video side is being done over at VP8, because Chrome is the first ones in. And like, WebRTC.org is actually a Google property, and if you look at their, let's see, I think this is it. No. General overview. So here in the general overview of their library, they just put it out there. Nope, VP8, that's it. That's what makes WebRTC. And you're kind of like, well, hold on, they haven't made that mandatory yet. That isn't part of the spec yet. But that's where they are. So that's one of the reasons why they're not picking it up. But they're plugins. People have built plugins for those, for both IE and Safari. So. Other questions?
You may have mentioned this, but there was a Google server you've been referencing, I think, as your site server.
Yeah.
Is that like an open server that they're running?
Yes. So I saw somebody say, you should use these for Chrome, so it might start doing user agent sniffing. I mean, I've been using it without an issue, but so you see here, I don't want turn in my code examples. It's all localhost anyway, so I don't care to put a turn server. But here I'm using a Google Stun server. So in the off chance that I was talking to my computer at home, I'll try Stun here. But I mean, this line is something I just kind of copy and paste around. There are turn servers that you can also use. You can pay for them, but because you're sending a lot of bandwidth through them, you generally need to pay something. Not a lot. Any other questions? All right. Thanks for letting me take up a lot of your time. And if you want 3D glasses, I can give them to you. It's awesome. Oh, yeah. All right.
Hey. Well, thanks for everybody coming out. Once again, if you need a valet or a validation, sorry. It's late. Raise your hand. Anybody? Nobody? Okay. Nobody else showed up. So yeah, that about concludes it. In another couple of weeks, we will be having a Austin AWPUG Meetup. AWPUG. This is AWPUG. I'm all screwed up. I think it's about time we go drink some more beer. Everybody with me?
Buffalo Billiards.
No, we're thinking Chicago House.
All right. That's the other group.
Chicago House is right down the road here. It's on about 7th and Trinity? Is that it? Yeah. So it's only about 2 blocks away. So everybody who's interested in talking more about real-time communication on the web, what you can do with it.
Or Python.
Or Python.
I mentioned Node way too many times.
And Node. We could talk about Node, or how we could replace Node with Python, if that's even feasible.
Yep.
All right, let's do it. And I don't know how many beers and chicken wings we have, but if you want to stuff some in your pockets and on your way out, that would be grateful.
I will fix those code samples before they go up. Roll in another.